All right. I hope everything is working. All right. So yeah, good morning, everyone, and we're going to discuss, for about 4 weeks. Yeah, for about 4 weeks before your midterm examination, we're going to talk about the various special techniques of integration. And you know that this is special techniques of integration because the reason why they are called special, so because when all the basic integration formulas cannot be used to integrate a function, then you can use this special techniques of integration, and they come in different process. We have solvable groups of trigonometric integrals. I hope you can hear me. Can you hear me? Can you get a yes?
Yes, sir.
Yeah, thank you. Solvable groups of trigonometric integrals, and you're going to use that whenever you were given, the powers and product of of trigonometric functions, and you can also apply it in powers and product of hyperbolic functions. You have heard me say powers and products of trigonometric functions when we discuss the integrals of trigonometric functions, na. And yun yung may mga malalaking powers. Say for example, 'di ba? I told you that if sine is present on the integrand, you must look for a cosine, no? So the sine and the cosine must go along together. So what will happen po if there is no cosine? If that is only sine raised on even power, sine raised on odd power, and then we're going to use the solvable groups of trigonometric integrals. We will also be discussing the integration by parts procedure, and this is used whenever a trigonometric functions get along together with another trigo or an algebraic functions, or when the integrand contains product of transcendental and algebraic functions. And then the trigonometric substitution, this will be used whenever there are presence of yung square root, the expression, the radical expression that you see in integrals leading to inverse trigo, like square root of a squared minus u squared, square root of a squared plus u squared, or square root of u squared minus a squared. When this is present but no longer on the denominator, okay, wala na sa denominator, like square root of x squared minus 4 dx. So how are you going to solve for this one? Diba, when you see x squared, there should be an x here, so that you can use the basic formula, na, diba? Or this should be written on the denominator, so that this will give us an inverse trigonometric function only with x here, right? So, but what if it's written this way, and then we can use the trigonometric substitution. The miscellaneous substitution naman is used whenever the integrand contains a fractional power. Okay, for example, you have integral of dx all over square root of x plus cube root of x. Okay, so we can use the miscellaneous substitution. For the half angle substitution naman, you will use this whenever, di ba, I taught you how to integrate, say for example, dx all over 1 plus cosine of x by multiplying this by the conjugate, di ba? Okay, but what if the given integrand contains 2 plus cosine of x? Multiplying this by the conjugate will not help us, because that will not lead us to either cosine squared or sine squared because of this 2. Right? So we can use the half angle substitution. And then, yeah, the integration by partial fractions. I know you are familiar with this one because you use this in some of the items in our problem set and some of the items in quiz. I think there are those who use integration by partial fraction. Yung integration by partial fraction is used whenever, say, you have dx all over x squared minus 1, di ba? This gives us an inverse hyperbolic cotangent. Oh, no, inverse hyperbolic tangent. But then again, when I discussed to you the integrals leading to inverse hyperbolic functions, we will modify the formula because you can use partial fraction to find the integral of those things. Okay? But for today, let's start with, well, I will be having a very short discussion on solvable groups of trigonometric integrals because I have already presented some of the forms to you. Okay? Like sine raised to an even power. or like cosine raised on odd power. I believe I have mentioned that no, on the last discussion natin as far as integrals of trigonometric functions is concerned. Okay, and this is the first group that is divided into three groups. Okay, yung first one is the group of sine and the cosine function, and this is when the integrals contains any of this form. Okay, integral of sine raised to mu cosine to the nu du, sine to the mu cosine to the nu du. Hold on. This is integral of sine to the mu cosine to the nu du, integral of sine to the mu du, and integral of cosine to the nu du. Okay? Hindi ko siya may edit dito sa sa laptop ko na to. Kasi wala akong ano dito. Tatakloban ko na lang. Takloban ko na lang. Sulat ko na lang. That's integral of. Then you may start writing. No? I was not able to upload this on our classroom. Yeah, like that one. That's integral of sine to the m u du and integral of cosine to the n of u du, where n or m element of positive integer. Okay. Case number one, when m is odd, factor out sine u, just ignore the du, and then change the remaining sign into cosine using the identity sine squared u equals 1 minus cosine squared u. Case number two, when n, the power of cosine. When n is odd, factor out cosine u and then change the remaining cosine into sine using the identity cosine squared u equals 1 minus sine squared u. And case number three, when m and n are even, and then you will be using this identity, the square identity for sine, that's 1/2 minus 1/2 cosine 2u, and the square identity for cosine, that's 1/2 plus 1/2 cosine 2u. And then group number two is the group of tangent and secant. You know, diba I told you that when tangent appears on the integrand, then you must look for secant squared. What will happen if there is no secant squared? Okay. I also mentioned that whenever there is secant on the integrand, then you must look for tangent. But what if there is no tangent on the integrand? Okay. And then this group tells us what to do. Right? Ayan, tama naman siya. So this is the second group, the group of tangent integrals containing integral of tangent to the mu secant to the nu du, integral of tangent to the mu du, then integral of secant to the nu du. And then case number one, when m is odd, when the power of tangent is odd, okay, you factor out secant u tangent u, you just ignore the du there, and then change the remaining tangent into secant using the identity tangent squared u equals secant squared u minus 1. And when n is even and greater than 2, you factor out secant squared u and then change the remaining secant into tangent using this identity. Okay? And when m, the power of tangent, is even, I have already given you an example of this. When m is even and the integrand is tangent only, use the identity tangent squared u equals secant squared u minus 1. And you will observe that there is no rule telling us what to do when n, the power of secant is odd. Okay? Kasi hindi siya kasama sa technique na to. And whenever the power of n is odd, you will be using by parts procedure. Na? And then for the group of cotangent and cosecant, actually similar lang yung rule for group 1, for group 2 and group 3. For group 2, palitan nyo lang siya ng cotangent and cosecant, and we will have this. Okay? So that's integrals of the form cotangent to the mu, cosecant to the nu du, cotangent to the mu du, and cosecant to the nu du. Right? So you have case number 1, when m is odd, you factor out cosecant u, cotangent u, and then change the remaining cotangent into cosecant using this identity. When n is even and greater than 2, when the power of cosecant is greater than 2, even, factor out cosecant squared u, and then replace the remaining cosecant into cotangent using this identity. And when m is even and the integral is cotangent only, you use this identity. Okay? So please take a screenshot of this. Kita ba? Sorry. Part by part na lang. Okay? Part 1. 1, 2, 3, 4, and 5. You just write this on a piece of paper later on after the class on your notebook. Then part 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then part 3, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? And let's have some example. So what are you going to do first is to identify saang group ba to kabilang. And after identifying the group, so madali lang naman siyang matandaan. If that is sine or cosine, then you go to group number 1. If tangent and secant, group number 2. Then cotangent, cosecant, group number 3. And then you try to look on the powers. So if it is in group number 1, you look at the powers of sine and the cosine, whether it is odd or even. As simple as that. Okay? Example number 1. You can cut me up if you have question. Which one is better? The red? Not striking in your eyes? Or black na lang siguro?
Black na lang, sir.
Black na lang. Say integral of sine to the 5 2x dx. Right? So that falls under group number 1. Okay? That's G1 point n m is 5 and this is odd. Okay? And then when you go back here, when m is odd, that's group number 1, case number 1. Tama? G1.1. Okay? That's group number 1, case number 1. Okay? And this is how you're going to do it. You keep your eyes on the board. Okay? According to the rule, you factor out sine u du. Say you have sine 2x dx, and then originally you have 5 sine, so you will have sine to the 4 2x. So the new form is sine to the 4 2x, sine 2x dx. That is still your sine to the 5. Okay, that's still your sine to the 5. Then after which you change the remaining sine into cosine by using the identity sine squared 2x is equal to 1 minus cosine squared 2x. So we shall now replace this sine to the 4. So you know that sine to the 4 is sine square 2x square. That gives you sine to the 4. And then you copy sine 2x dx. So you now have integral of sine squared 2x is 1 minus cosine squared 2x, then raised to the second power. That is now your sine to the 4. And then you just simply copy sine 2x dx. Okay? So from the original given integral of sine to the 5 2x dx, we now have a quantity of 1 minus cosine squared 2x squared times sine 2x then dx. And then from here, yeah, diba? There is a cosine, so you can now let u. So the rule of the sine and the cosine still applies here. Since you already have cosine, then there must have sine, diba? I told you that when cosine appears on the integrand, you must look for a sine function that will go along together with dx, and that is what we are going to do here. Now, yung mga basic rules na shinare ko sa inyo in trigonometric functions, you will observe na yun yung ina-achieve natin by using the principles stated earlier. Okay? You now have cosine here, so you have sine 2x dx that will go along together. So you have cosine 2x, that is your u, and then du is negative sine 2x, then derivative of 2x is 2 dx. Right? And then you now have negative 1/2 du equals positive sine 2x dx. And then we can now change the variable. Integral of 1 minus cosine squared, that's your u square, right? That's cosine squared, that is your u square square, all right? Then sine 2x dx is your negative 1/2 du. All right, and then we can now expand and then integrate. So you have negative 1/2, okay? Integral of 1 minus 2u square plus u to the 4 du, right? That's 1 minus 2u squared plus u to the 4 du. Integrating, you shall now have negative 1/2. Integral of 1 du is your u, okay? And then minus 2u cubed over 3, then plus u to the 5 over 5, then plus c. And then from here, you can now introduce that negative 1/2, and then you will replace u by cosine 2x. I'll go up. That's negative 1/2 u minus 2u cubed over 3 plus u to the 5 over 5. So you have negative 1/2 times u minus 2u cubed over 3 and plus u to the 5 over 5. You take a look on the powers. There's a pattern. You can just introduce this negative 1/2 and then you replace cosine u by cosine 2x. So that's negative 1/2 cosine 2x, right? Plus 2/3 cosine cube 2x. Oh no, it's not 2/3. It's 1/3 na because we multiply it by 1/2. It's 1/3 cosine cube 2x minus 1 over 10 cosine, to the 5 2x. And then you add c. Right? You look at the powers. This is 5. And then you start at 5, then 3, and then 1. And then alternating ang sign. Ang problemahin nyo na lang yung coefficient. And then you use the binomial theorem. Okay. Number 2. Say integral of sine squared, say 3x, then cosine cube 3x dx. So the sine and the cosine go along together as part of the integrand. Okay, they have the similar parameters but different in powers. The sine is raised to the second power, which is even, and the cosine is raised to an odd power, which is 3. Okay, so you have m, the power of sine, which is 2, and then n, which is 3. So going back here to the rule, when m is odd, factor out sine u. When n is even, we will be using this identity. Right? Diba? The power of sine here is even, and the power of cosine is odd. So this is even, and this is odd. Now, when the odd and even powers appear together, masusupersede ni odd si even. So we will be using case number 2 of group number 1. Ulit, when even and odd powers appear together, ang gagamitin nyo ay yung odd power. Okay? You're going to consider the odd power. So here, we will be using group number 1. I hope that makes things clear. Group number 1, case number 2, when n is odd. Okay? Then you now have integral of sine square 3x. Okay? When n is odd, factor out cosine u. So in this case, that's cosine 3x that will go along together with dx. And then the original cosine cube will become cosine square 3x. Now, I would like to highlight that cosine 3x. Okay? You now have this cosine 3x, and then we're all good because this is already sine. The sine and the cosine appears together. Okay? And then the only thing we need to do is to replace this cosine squared by 1 minus sine. Because we want the function on the integrand to be all in sine because we now have cosine here. Okay? Let me rewrite this first. So the cosine squared 3x is 1 minus sine squared 3x. Okay? And then let me just copy the remaining terms. Sine squared 3x. And then what did you notice? Okay? The functions are now written in sine, except for cosine that will go along together with dx, because we wish to let u be equal to sine 3x. All right? Then du is what? Cosine 3x 3 dx. So we now have 1/3 du equals cosine 3x dx. And we now have integral of sine squared 3x is your u square times the quantity 1 minus u square. And then, what is cosine 3x dx? 1/3 du. And then you now integrate you now distribute u squared, each term inside the parenthesis. Sorry. So you now have, if I'm speaking a little faster, you call my attention. You now have 1/3 integral of u squared times 1 minus u squared times u squared du. And then you have 1/3, all right, integrate u cubed over 3 minus u to the 5 over 5, then plus c. Then you can also explore this by putting limits, no? Making it definite integral. It remind me, 1 over 9, then u is sine cube 3x minus 1 over 15, then you have sine to the 5 3x, and then you add, and you're done. So we now have case number 1, case number 2. So let's take the case wherein n or m is even. You can follow me on board number 3. Right. Yeah, sorry for the limitation of my device. Ang tagal niya, sorry. Magbablock na tayo dito. Yes, anything?
Sir, yun dun po sa may ano po, yung sa may sign ano po, integrals of the form po sa group 1 po. So
Group
sadya po bang yung number 2 po, sir? Yung condition 2 po, sir, sin m raised to u po yun. Ay, sin raised to m u po yun, sir.
Hold on.
Sin
number
raised to, apa, yun to po.
this one?
Ito po, sir, yung nasa taas po.
Ito?
Yung apa.
This is sin to the m.
Apa, sir, ganun po talaga, sir. Okay pa.
The power of sine is m. The power of cosine is n. Ibig sabihin, itong mga rules na to, gagamitin nyo siya, number 1, case 1. Kapag si sine at saka si cosine ay magkasama sa integrand, pero pareha silang may power. Di ba ang itinuro ko sa inyo dun sa basic integration ng trigo function ay, si sine ay may power, si cosine ang power ay 1. Tandaan niyo yan? Di ba? Dapat ganon. Kapag si cosine ay may power na kahit ano, dapat si sine walang power na kahit ano. In this case, sila ay parehas na may power. Okay? Ito namang number 2, si sine lang ang nasa integrand, pero naka-raise siya ng power, either odd or even. So kapag if sine appears alone, appears alone on the integrand raised to an odd power, gagamitin mo ito, case 1. Okay? If sine appears alone on the integrand raised to an even power, gagamitin mo itong case 3. Okay? The next, yung number 3 naman, ito. Yung the third form. If cosine appears alone on the integrand and raised to an odd power, you use case 2. Okay? So if cosine is raised to an even power, appears alone on the integrand, you use case 3. Example number 1. Sine appears alone on the integrand raised to an odd power, we use case 1. Okay? Example number 2. Where is it? Sorry. Sine and cosine appears together. Okay? Sine is raised to an even power, it's an m. And cosine is raised to an odd power, that's odd. Okay? And then, kapag sila ay magkasama, pero ang isa ay even, ang isa ay odd, yung odd ang inyong susundin. So this will fall under case group number 1, case number 2, where n is odd. Okay? Hold on. Baka you are misinterpreting that this is case 1, case 2, case 3, ha? No.
Aba, sa yun pa. Ganito lang po.
Hindi siya, ito yung mga forms. I shouldn't be writing I.
Bale, sir, yung tatlo pong to, sir, yung forms po. Tapos ang
Ito yung
gagamitin po,
cases.
sir, ito pong case to 3.
Yan. Ito ay forms lang. So whenever you see any of this form, itong tatlong to, they are in one group. Okay? So pero ito yung mga cases. Okay? So ito sinasabi lang na kapag si sine and si cosine magkasama, kapag si sine ay nag-iisa, kapag si cosine ay nag-iisa, okay? And then titingnan yung powers. Okay na tayo done? Okay, so like this one now, the sine and the cosine appears together. Sorry, bagal ng laptop ko ngayon. Number 3, what do you want? Let me see. So, say for example, you have integral of, and it's blinking. Hold on. Yeah. Integral of, what do you want? Sine raised to an even, say 2x. Wag niyo munang isama dito yung magkakaibang parameters, ha. Pag magkaiba ang parameters, obviously hindi uubra tong technique na to. So we will be applying the by parts procedure. Okay? So just think and consider those functions with similar parameters. Different powers na lang. Okay? Say sine squared 2x. So say for example, this is 4. Okay, so ano ang gagamitin nyo? Yung 1/2 minus 1/2. Sir, paano po pag may cosine raised to, what do you want? Even or raised to odd? O di yung case number 2 pa rin. If cosine is raised to an even power, edi yung group number 3. Eh sir, paano po pagka cosine lang? Cosine raised to an odd power, group number 2. Ulit, wag malilito sa mga forms. Itong number 1, sine raised to an odd power. Okay? Kung ito ay cosine lang, dito kayo sa group number, sa case number 2. Pero ito pa rin yung process. Ito pa rin yung process. Mapapalitan lang itong cosine to the 4, cosine 2x, magiging cosine squared 2x equals 1 minus sine squared, and then everything is in good place kasi mawawala lang yung negative dito. You getting my point? I hope so.
Yes, sir.
Okay? So basta pag binigyan ko kayo ng like this one, sine to the 4 lang. O di isipin nyo na yung ginagawa kong process can also be applied kapag siya ay cosine raised to the 4 lang. Or kapag sila ay may magkasamang cosine and sine raised to an even power. Okay, what do you want? Sama ko yung cosine? Or wag na po muna. Okay. Sine to the 4 2x dx. Where m is even. Okay, madali lang to. So you have to use 1/2 minus 1/2 cosine 2x, and then this 1/2 minus 1/2 cosine 2x is your sine squared. That's sine squared alone. So ito ay gagawin yung 2. Now, if this is 6, o di gagawin nyo aring 3. You getting my point? Yeah, I hope. And then, dx. So you will now expand integral of 1/4. Yes.
And then sir, kapag naman po, odd po, ibang case
Pag
po yung
add,
papatakan.
o di case number 1 na, hindi na pwede to.
Sige po sir.
Right? You have to be very, very careful in using the cases. Identify whether the powers is odd, even. I think hindi naman, I decided to group it into 3 para mas guided kayo para hindi na kayo malilito. Yun nga lang, pagka magkasama yung even and odd powers, laging nasusupersede ni odd si even power. So doon kayo sa odd. Right? You have 1/4 minus, then multiply, then times 2. So that's 1/2 times 1/2. That's 1/4 times 2. That's 1/2. Cosine 2x. And then square plus 1/4 cosine squared 2x dx. Now, this is integrable. This is integrable. This is not yet integrable. So we will apply another 1/2 by 1/2, 1/2. Okay? So plus, not responding. Hold on. So this cosine squared x, papalitan natin siya ng 1/4 times 1/2 plus 1/2 cosine, we will double the angle. It will now become 4x. Then close dx. And then we will copy everything. Minus 1/4. Then integral of. And then we are now ready to integrate after introducing 1/4 and 1 to each term inside the parentheses. So you now have integral of 1/4 minus 1/2 cosine 2x plus 1/4, 1/2, 1/8, and then you will add that 1/4 and 1/8. So pwedeng, it's up to you kung anong gusto nyo. Pwedeng i-integrate nyo na yan, and then saka nyo i-add yung 1/4 and 1/8 after integrating. 1/4 plus 1/8 is 3/8. Yeah, it's 3/8. Then minus 1/2 cosine 2x. And then we continue. 1/4 times 1/2 cosine 4x is 1/8 cosine 4x dx. And then 1/3/8, that's the sum of 1/4 and 1/8. Then copy and then copy. And you will observe there are no more powers and everything is integrable. So kahit hindi na kayo maglet-let ng u dyan, so integral of 3/8 is 3/8x. Then this is 2. You take the reciprocal of that, multiply to 1/2 in front, so that will become 1/4. Integral of cosine, positive sign, plus, this is 4, multiply to 8, that's 32. That's 1/32, integral of cosine, sine 4x plus c. Right? So that's the integral of sine to the 4 2x dx. Okay? What if, sir, magkasama sila? 3, 4. What do you want? You can give me example, sir. Try natin yung power. Sir, pwede po ba kapag ka ang power ay fraction? Pero dapat yung isa hindi. No? So, ito yung form na magkasama yung powers na fraction. Say, cosine. Cosine to the 6x. That's quite large. No? Laki na nun. Gawin ko na lang siyang ano. Hindi ko malaki, sorry. Cosine to the 5. X, and then sine raised to 1/2 x dx. So obviously, we will not consider the power of sine since it's a fraction. So readily, this will give you a hint that you will be using group number 1, case number 2. So i-ignore nyo na to kasi hindi naman to integer So ito lang siya. Alright? Sir, paano pag ito even? Hindi rin siya uubra kapag even. So we will be applying by parts procedure kapag ito ay even. Kasi this is, hindi ka naman pwedeng maglabas ng isang cosine. Tapos, di ang matitira dito ay, kung siya ay 6 yung kanina. Di ang matitira dito ay cosine to the 5. Wala ka namang identity na pwedeng gamitin dito. Kasi it's an odd power. So have Integral of case number 2, you leave one of the cosine that will go along together with dx. So originally, you now have cosine to the 5, and then you will have cosine to the 4x here, and then there's another cosine here, and that gives you cosine to the 5. And then you just simply copy sine raised to 1/2 of x. Ang layo, sorry. And then this is your cosine x dx. Okay? And then from here, you can now let you can now replace cosine to the 4x by 1 minus sine squared x, that is your cosine squared. Raise it to the second power to make it cosine to the 4. Then copy sine 1/2 raised to 1/2 of x, copy cosine x dx. And you will observe again that everything is now written in sine except for cosine that appears together with dx. So you can now let u be equal to sine x, then du is cosine of x dx. So you now have integral of 1 minus u square u raised to 1/2 du. I hope you can follow. And then what are you going to do next? You expand, no? And then introduce u raised to 1/2. Integral of 1 minus 2u square plus u to the 4 times u raised to 1/2 du. And then you have u raised to 1/2 minus 2u. You are adding the powers. 2 plus 1/2, that would be 5/2. Am I right? Yeah. Plus, sorry, u, then 4 plus 1/2, that would be 9/2 du. And then you integrate u 1/2 plus 1, 3/2. From 1, this will become 3, this will become 7, this will become 11. You just simply add 2. 3/2, then 2/3. Minus 2 u 7/2, 2/7. Plus u raised to 11 over 2, 2/11. And use add c. And done. Kapos na naman, sorry. Then you write it back to the original given, which is sine. So sine 2/3 sine raised to 3/2 x minus, what's that? 4/7 sine raised to 7/2, yeah, 7/2 x plus 2/9, 2/11. 11 sine raised to 11/2 x plus c. Right? 4. Can I now go on with the third group?
Sir, pwede po kaya gamitin yun, sir, kapag negative po yung
Of course.
pag even po.
Alin ang negative? Alin ang negative? Power ni sine or power ni cosine?
Power po nung sine po.
Sine, yes. Oo. Basta ang rule natin, dun sa m or n, if this appears together, sine raised to m, cosine raised to n, ang isa sa kanila ay even integers. Positive. Ay, not even. Ang isa sa kanila ay integer. Yung isa kahit ano, can be positive, can be negative, can be fraction, can be decimal. You get my point? So, ibig sabihin, this particular technique for number 4 can also be applied if you have cosine raised to, it's an odd, raised to 11x, sine raised to negative 5x dx. Medyo mahaba lang talaga to. It's 11 na eh. Diba? Okay, tayo done? So,
Okay,
pwede din siya ng sine. Sine raised to odd, na? Sine raised to an odd power, then cosine raised to anything, whether negative, positive. So, ibig sabihin, sir, pag halimbawa, sine to the 5x over secant squared x dx. Pwede po ba yan? Pwede, because you can rewrite 1 over secant into cosine. Baka sasabihin nyo, ay, not integrable po. Kasi, wala siya sa group number 1. Because sine and secant appears together, hindi naman pwede yun, di ba? Ang tinuro ni sir, sine and cosine lang. So, hindi pwede. But then again, when you try to look, ay, secant squared x on the denominator, that can be written as cosine kasi reciprocal identity. Okay? So, magiging cosine squared na siya. So, sir, paano po pagka dito yung secant? Di ba? I'm just giving you several forms, but I'm not solving those forms kasi I have already example. Okay? So, I'm just giving you scenarios kasi baka ma-encounter nyo. Hindi naman tinuro ni sir eh. Sine and secant magkasama, hindi naman tinuro ni sir. Okay? So, whenever sine and secant appears together, so you can convert secant into cosine. Say, for example, you have sine to the 5x, then secant squared x dx. Ay, hindi pwede kasi si secant kasama ni sine. Dapat kasama ni sine si cosine. So, that should be written of the form. You can still apply. This will still fall on source, saan siya magpo-fall? This will still fall on group number 1, case number 1, GIP 1.1. Okay? Because you can rewrite this as sine to the 5x cosine raised to negative 2x dx. Sine and cosine appears na together. Alright? Question? Clarification?
Sir, pag pareho pong negative yung ano po,
Ay,
pwede pa
that's
yung po. Hindi na po.
pwede. Kasi parehas na siyang negative. Let me see. Kung parehas na negative, pwede naman. What do you, yeah, pwede, I think. Let me see. Let me inspect first before I say yes or no. Kasi kung ito ay negative, sine raised to negative 5x, and then cosine raised to anything, ito na lang, dx. Kasi I should have to have sine. So, hindi pwede kasi magiging 6 na siya. Di ba? Kapag sinimplify ko to, applying the rule, magiging negative 6 na to kasi I should have to have sine x here. Right? Di ba? I think pwede nga, no? Pwede nga. Yeah, pwede. Hold on. Kasi you can write this as sine square raised to negative 3. Negative yon. So, ibababa mo siya. Sa ilalim ka mag-expand. Hold on. Kasi that's negative 6 eh. Ito ay sine. So, ito yung gagawin mong 1 minus u square raised to negative 3 du. Ay, hindi pwede. Hindi pwede. Kasi magiging mapapasa ilalim siya. Now, hold on. Pagka ganito yung given nyo, okay? So, halimbawa, naging ganito na. Thank you for this question. Kasi I might include that on the exam. Kasi I already found a way on how to deal with this problem by just looking at it. Tama. Pagka ganito, ang mangyayari dyan is magiging na siyang integral of du all over 1 minus u squared to the third power. In that case, pwede nyo nang gamitin ang integration by partial fraction. So you can employ 2. du. Sorry. Written as du over 1 minus u squared to the third power. Okay? So, yun. you take note of this. If the powers, kaya ang notation natin dun sa m and n are positive integer, kasi pag negative, it will employ another techniques of integration. So dito, para sa form na to, dalawang techniques of integration ang gagamitin natin. One of which is itong solvable groups of trigonometric integral, and then after converting it from trigo to algebraic, gagamit na tayo dito ng partial fraction. So what are we going to do? I-decompose natin ito into partial fraction. Okay tayo dan? Hello?
Okay po.
So dalawang techniques ang gagamitin. But still, solvable pa rin siya. It's still integrable. Hindi nga lang yung technique na solvable groups, dalawang technique. So, ibig sabihin, dalawang beses kayong magpapalit dyan. Okay? Sir, paano po pagka raise to parehas na fraction? Yun ang hindi pwede. Part by parts na talaga siya. Alright? Everything's clear? Hello? Yeah, thank you for your mga comments at mga questions. What else? You think of some forms pa para na-discuss natin. Baka mamaya may encounter nyo.
Basta sir, kapag po fraction, hindi na po pwede po.
Basta pag fraction, hindi na pwede itong technique na to. Pero we can employ another technique. By parts na tayo nun. So that's why, before studying my examples, you have to identify first the techniques. Kung alin bang techniques ang applicable. Kasi there are a lot of techniques that I'm going to teach you. No? So yung mga mention ko earlier, there are a lot. And sometimes, ang isang problem na pwedeng gumamit ng tatlong techniques of integration, and that might appear, no? Mag-a-appear siya dun sa ating sa ating mga exercises and exam. Pwede din siyang ang isang problem pwedeng gumamit ng 3 or more, 2 or more special techniques. Pero hanapin niyo yung mas appropriate kasi when you use a not so appropriate technique, sobrang haba ng solution. And you will encounter that now as we get along with this lesson. So there were cases na dalawang special techniques ang gagamitin. Say for example, by parts, and usually ang nagkakasama diyan ay yung miscellaneous substitution and trigonometric. So yun yung malimit nagkakasama. Not nagkakasama, but yun yung malimit na ang isang problem pwede mong i-solve using trigonometric substitution and miscellaneous. But between the two, mahaba yung solution ng isa, yung isa convenient and mas maikli. So yun yung munang aralin nyo. Paano ba na-identify ang technique na gagamitin? So it comes with the different forms. So ito yung mga first group of forms ng special techniques of integration. Okay? So you have tangent raised to, ang haba ng 6, raised to 4, 1/2 of x, then dx. Okay, it's an even. I think I already have an example of an even power for tangent. Speak ko na yun ha. Alam niyo na yung gagawin doon. Or, sige, bigyan ko lang kayo ng isa. So that's tangent to the 4 1/2 x dx. So what are you going to do is to reduce this into tangent square 1/2 of x, and then tangent square 1/2 of x dx. So that gives you tangent to the 4. And one of the tangent square, gawin nating secant square. So you have tangent squared 1/2 of x, and then this tangent squared, we will make it secant squared 1/2 of x minus 1 dx. And then you can now introduce tangent squared 1/2 x, each term inside. So you will have tangent squared 1/2 of x, secant squared 1/2 of x dx. And you now see that secant squared appears together with tangent squared, and we're all good here. This is already integrable, and this you can now turn this up to a power formula. Then minus integral of this tangent squared x, you just simply multiply it to -1. That's why this is minus tangent squared 1/2 of x dx. But when you look on the second integral, the second term, tangent raised to 2, it's still even. So it's not integrable kasi we do not have, a direct formula for the integral of tangent raised to an even power. So you will write this as secant squared 1/2 of x minus 1 dx. And then you do the same. Integral of secant squared 1/2 x dx minus plus integral of dx. And then you just simply copy this. Okay, let me just copy that one. Control V, where is it? and then copy it here again, and then you can now integrate. You still want to do the substitution? Ganito na lang. Na? You copy tangent, yung tinuro ko sa inyo. Tangent. Then you add 1 to 2, so that will become 3. You copy 1/2 of x, because there's already secant squared. Okay? And then you just multiply this 3 and 1/2. 3 times 1/2 is 3 halves. Then you get the reciprocal, write it in front. Okay? Then ito naman, you just get, this is direct formula, integral of secant squared u du. Alright? So you can just simply get the reciprocal of 1/2, and that is 2. And then integral of secant squared is tangent, then 1/2 of x. And then integral of dx is simply x plus c. Okay? So, tinuruan ko na naman kayo dyan, na how to do this in simplest way. So, kung mayroon kayong tangent to the 10, you just subtract 1 from 10, and then, yeah, then the power of tangent will start from 9, 7, 5, 4, 3, then 1, and then x. Mas madali na. Integral of tangent to the 10, say 5x dx. So you start by, you start the power 10 minus 1, that's 9. So you have 10, sorry, it's tangent to the 9, 5x. And then you just simply multiply this, 9 times 5, that's 45. Write it here. And then tangent to the 7, 5x, multiply 35, 7 times 5, then alternating, plus, minus. And then minus, plus, tangent to the 5, then 5x, multiply 25, then plus, minus, tangent, cube, 5x, multiply 3 times 5, 15. And then plus, tangent to the 1, 5x, multiply 5 minus x, then plus. And that gives you the integral of tangent to the 10, 5x. If you do this tangent to the 10, if you apply the normal process, sobrang haba niyan. Kasi like ito, 4, how many lines? 1, 2, 3, 4. So, ibig sabihin, this is more than 10 lines to. Ang daming palit eh. Right? And I think I have already given you an example of secant. 6. Integral of secant. Say, what do you want? Secant to the even or odd? Hindi pala pwede ang add. Pwede lang kung may tangent. Diba? Pwede kung may tangent. We will fall under case number 1 of group 2. When n is odd, when m is odd, factor out secant u tangent u, and then change the remaining secant into tangent. So, sige, gawin natin. Ito ay okay lang. Hindi. Secant to the 5. X tangent x dx. Ay, hindi. Madali pala to kasi maglalabas lang ako ng isang secant eh. So, meron na akong secant tangent. Wag to. Ano na lang. Ano na lang. Tangent. Cube. Tangent cube x square. Then cube root of secant x square. So now, if this is x squared, you must secure an x in front, then dx. Then okay na siya. Okay? If that is x cubed, you must look for x square here. Okay. So we have here tangent cube. So that's your n equal to 3 and m is 1/3. M the power of secant and the power of tangent. So ito ay add. So case number ano tayo? Case number 1 when n is add na. Group number 2. So you have integral of x tangent squared x squared, and then ang sabi doon maglalabas daw tayo ng secant view tangent view. So we will have secant view tangent view, okay, dx. And then originally you have x here. Originally you have tangent cube x squared. So this will become tangent squared x squared, and then this is cube root of x squared, but we already have secant x squared here. So this cube root of secant x squared will become secant raised to 1/3. So 1/3 minus 1, so that will become negative 2/3. So you secant, this is now raised to negative 2/3 x squared. You're with me? When you multiply all those things, this bunch of expression here, that will just simply give you this one. X tangent cube x squared, cube root of secant x squared dx. Okay. And then after which, you now change this tangent squared x into secant, and you will observe that everything is written in secant. So you have integral of x, then that's secant squared x squared minus 1. Then you just simply copy secant raised to negative 2/3 x squared. Then you copy secant x squared tangent x squared dx. All right? So then you can now let u be equal to secant x squared, and you know that du is 2x, yeah, 2x secant x squared tangent x squared dx. Saan galing yung 2x? Derivative of x squared. But you only have x secant squared x tangent x squared dx. So alam niyo na ang gagawin. You can now remove this 2 and write it here. You have 1/2 du. Okay? And then by change of variable, paki-recall ako nito. That's x secant squared x squared minus 1. So you have integral of, dito na lang kaya pa naman. Integral of secant squared x squared minus 1, that is your u squared minus 1. And then you have secant raised to negative 2/3. That's your u raised to negative 2/3. Then tapos, you have secant x squared tangent x squared dx. There's x in front. So you have 1/2 du. Okay? Then introduce 1/2 u 4/3. Am I right? Yeah. Minus u raised to negative 2/3 du. 3 times 2, that's 6, minus 2, that's 4. Yeah. And then you have u 1/2 u raised to 7/3 3/7 minus 1/2 u, sorry, I forgot to write the integral symbol. U raised to negative 2/3 plus 1, that's 1/3. All right, then 3, and then plus c. And then you now have 3/14. Then we write it back to secant. Secant raised to 7/3 x squared minus 3/2 secant raised to 1/3 x squared plus c. Okay, and done. Dapat pala dito na lang sa baba. Sorry, kakat ko. And then you will apply the same technique whenever you are integrating cotangent and cosecant. Parehas lang yung rule na ina-apply natin for cotangent and cosecant, tangent and secant, and they will only differ in sign. At saka, of course, you know naman that the derivative of cosecant is negative. And the derivative of cotangent is also negative. Number 6, you can just tell me if I can stop now, if I can proceed with the next technique. Say integral of, what do you want? Cosecant. Cosecant to the 6. Sige. 1/6 y dy. Okay, that's cosecant to the 6, 1/6 y dy. Group number 3, case number, I think it's number 2. No? Group number 3, case number 2, when m, the power of cosecant is even and greater than 2. Factor out cosecant squared u and change the remaining cosecant into cotangent by using the square identity. Okay? So according to the rule, you must factor out cosecant squared 1/6y dy. Right? And then after which, you will replace that cosecant to the 6, and that's cosecant to the 4 into cotangent by using the identity cotangent squared 1/6y plus 1. And then this is to the 4. This is just cosecant squared. Raise it to the second power to make it cosecant to the 4. And then you just simply copy cosecant squared 1/6y dy. Okay? So, dito medyo magiging clever ako in giving items, no. You have seen it in our quiz, 'di ba? Yung iba sobrang komplikado nung ginawang solution, but once you notice the pattern, madami doon, like yung like yung square root of x dx all over e to the square root of x plus ln of x, 'di ba? When you rewrite that, that will just simply become e to the square root of x dx. Pagka sinimplify niyo yung item na yon, ay hindi pala, magiging siyang e to the negative square root of x dx. Along with yung isa pa, yung akala nyo komplikado, yung 1 over cosine squared, the quantity ln x raised to 2x. Kapag kinonvert nyo yon, ipa-factor nyo lang yung secant squared x ln x to the 2x. Then ang matitira doon, yung derivative ng ln x raised to 2x. Ang integral lang doon is tangent. Yeah, that's tangent x raised tangent x no. Tangent of x ln sorry, tangent of ln x raised to 2x. Then there's 1/2 here. Plus C, yun lang siya. But it's worth 5 points. It's worth 5 points if you were able to identify or to rewrite it in simplest form. Now, anyway, so we can now let u here be equal to cotangent 1/6y, and then you know that du is negative cosecant squared 1/6y, then 1/6 dy. So you have negative 6 du equals cosecant squared 1/6y dy. And then you now have integral of u squared plus 1 square, then negative 6 du. Okay, then you expand negative 6 u to the 4 plus 1. No. U to the 4 plus 2u square plus 2u square, then plus 1 du. And then you now have negative 6 integral of, integrate na tayo. U to the 5 over 5 plus 2u cube over 3, then plus 1, then du. Plus C pala, sorry. Ano ba? You now have negative 6 over 5, and u, that's cotangent to the 5 16y minus 6 divided by 3, that's 2. 4 cotangent cube 16y minus 6. Hindi nyo naman pinapansin ang aking error. This is you. Nag-integrate na eh. Minus 6 cotangent 16y plus c. Right? Can you check that one up? Baka may na-miss ako.
Tama po, sir.
So, alam niyo ang gagawin niyo kapag secant is raised to an even power. Diba? What did you notice? Diba? This is cosecant raised to an even power. So, 6 minus 1, that's 5. And nag-start tayo ng 5. 5, 3, then 1. And then, lahat sila ay negative kasi cosecant. So, kapag cosecant, alam niyo ang gagawin niyo. Say 7. Integral of secant raised to 8. Raised to 8. Say 3y dy. So, mag-start kayo ng 8 minus 1, that's 7. So, you have, meron akong mga proof nito. I compiled it into 108 pages ng thesis ko. So, meron akong ano niyan. So, that's 8 minus 1, it's 7. So, you have, start ka ng tangent. Tangent to the 7. Then 3y. Then multiply mo siya. 7 times 3. That's 21. And then, all is plus. Kasi siya ay tangent squared x plus 1. Eh, di ba ito ay plus kapag ka to the 4th power? Yeah, di ba? To the 4th power. Right? Hindi, pala. Kasi magpa-factor ka ng secant square. So, to the 3rd power na siya. Kasi matitira secant to the 6. Eh, ito ay plus. So, lahat ay plus yon pag in-expand mo. Alright? So, that's tangent to the 7, 3y, plus tangent to the 5, 3y, all over 5 times 3, 15, plus tangent to the 3, 3y, then 9, plus tangent to the 1, 3y, times 3, and then you add c. Okay? Simple as that. Any more question, clarification? None? Everything's good? I will give you the exercises. Upload ko na lang sa sa classroom natin. Ipo-pull out ko lang from my other source. Ba't ka ba hindi ko na upload to? Sorry. Okay. Question, clarification before I proceed with the next technique. And this will answer yung question natin whenever secant and cosecant is raised to an odd power. You just explore na lang to ha. Lagyan nyo ng limit, then pataasin nyo yung power. What will happen kapag siya ay may square root of y? Eh di kailangan nyo ng over square root of y. You getting my point? O sige, ito, halimbawa. What are you going to do whenever your integrand contains cotangent cube x over the square root of cosecant x? Hindi ko isosolve. Sabihin nyo lang sa akin kung anong gagawin nyo, kung saang case siya nagpo-fall. So you have integral of cotangent cube x all over cosecant square root of cosecant x dx. Anong gagawin niyo dyan? Sir, yung cosecant nasa ilalim. Eh di pag ginawa kong, pagka nira-write ko to, magiging cotangent. Magiging sine pala. Di ba?
Sir, group 3, case 1 po.
Case 1. So, hindi mo siya gagawin ganito.
Po, sir, cosecant raised to negative 1/2 po.
Pero, yung cotangent, pwede mong gawing di ba? Yung cotangent, pwede mong gawing cosine x over sine x to the 3rd power to the 3rd power. Sine raised to negative 1/2 of x dx. Di ba? So, ano nang form siya? Eh, di group number 1, cosine cube x, sine 3 nasa ilalim, negative, negative 1 half minus 3 negative 7 halves x dx. O di group number 1, case 2. Right? Tama? Hello? You agree
Apa,
with
sir.
me? Yeah? Di ba? You agree with me? Eh sir, anong gagawin namin? Eh bakit niyo pa ba pahihirapan ang sarili niyo na gagamit kayo ng ng identities? Eh di ba meron na nga tayong rule para dito? Ang gagawin mo lang ay are. Cotangent cube x cosecant raised to negative 1 half of x dx. Mas madali are kesa sa i-convert mo ng sine and cosine. Eh sir, mas komportable kasi ako sa sine cosine. Eh di go, walang problema. Eh kung doon ka komportable sa sine and cosine eh. Okay? Walang problema yan. It's either you transform it into cosine and sine kasi lahat naman sila eh, di ba? Yung tangent at saka yung secant, pwede niyo siyang i-convert ng cosine and sine. Cotangent, cosecant, pwede niyo siyang i-convert ng cosine and sine. However, pag kinonvert nyo, baka hindi na siya mag-follow ng rules dun sa group number 1. You get my point? Yan.
Yes po.
So, ito mas madali na kasi sige, solve ko na lang to. Just to tell you na mas madali ito kung dito nyo siya isosolve kaysa sa gagawin yung cosine and sine. Kaysa hindi nga namin naiisip na gawing cosine and sine yun eh. Kayo lang naman ang nakaisip. No. But that might happen. No? That might happen. Lalo na kapag hindi nyo makitaan ng rule dyan, so baka there's something wrong. Baka I need to use this reciprocal identity. I have to rewrite the given into this and yeah. So that's why I'm telling you to use the appropriate formula and to use the appropriate technique. Control Y, yeah. 8, solve natin. Cotangent cube x over square root of cosecant x dx. So, yun na. Gawin mo lang tong cotangent cube x cosecant raised to negative 1 half of x dx. So, again, group number 3, case number 1, you pull out one of the cotangent. So, this will become cotangent squared and one of the cosecant. So, this will become cosecant. Maglalabas tayo ng isang cosecant, negative 3 halves of x. And then cosecant of x, cotangent of x, dx. Okay? After doing the factoring, you verify this first, whether that is equal to this and equal to this. Okay? Equal ba? That's cotangent squared x times cotangent of x, that's cotangent cube. And when you multiply these two, you have cosecant raised to negative 1 half. Then, cotangent squared, that's cosecant squared x minus 1, cosecant raised to negative 3 halves x, cosecant x, cotangent of x dx. And then let u equals cosecant of x. You know that du is negative cosecant of x, cotangent of x dx. And you're done. U squared minus 1, that's your cosecant squared x minus 1. Then cosecant raised to negative 3 halves is u raised to negative 3 halves. And this whole thing is your negative du. And then, you now have negative integral of u 2 plus negative 3 halves. That's 1 half. Boom, 2, 4, yeah. Minus u raised to negative 3 halves, then du. Negative u, 1 half plus 1, 3 halves, 2/3. Minus, plus u, negative 3 halves plus 1, negative 1 half. Balik ko sa minus. Get the reciprocal. Minus 2 plus c. Okay, and then negative 2/3 cosecant raised to 3 halves of x minus 2 cosecant raised to negative 1 half of x plus c. And done. All right? Question, clarification? None? Hello?
None po ata, sir.
Putulin ko yung recording natin na.
Then start ko na lang ulit siya dun sa ano.